All right, so this video is going to be for the intro to polar coordinates. And one of the crazy things about polar coordinates is we're going to have to be on a whole new coordinate plane. I guess it's not a coordinate plane, it's a polar plane. And there's this thing called the pole, which would be like the origin. And then there's all the stuff that happens around it. So it's actually really fun and it's a great unit. So we're going to do a couple things here to introduce it. I'm just going to do a few things. Just a review, but then I'm going to also show you what some polar graphs look like, which we won't be doing today. We'll do later on in the unit, but I think it should be a lot of fun. So do your work, stay encouraged. You can do this and ask lots of questions. But polar graphs and polar equations and all that stuff is a whole lot of fun, and it really opens up a lot of doorways into doing some pretty cool math. So I hope you enjoy it, and we'll see how it goes. Today we're just going to introduce it and just kind of learn how to plot points. Just like you learned how to plot points in a coordinate plane, we're going to learn how to plot points in a polar plane. Simple enough, shouldn't be bad. All right, so I'm going to share with you my screen, and we're going to kind of get going here. So first, let's take a look at some of the notes that we've got going on here, right? Intro to the unit, right? Couple of things that you'll find why I'm asking these. They'll show up later in the unit, but should be okay. Just from the previous units that we've done, can you find the sine of theta given this terminal point? Hopefully the answer is yes, right? So if you were to plot this in the coordinate plane, it'd be -6 and 8. We draw a triangle. There's theta, right? And so then -6 would be the x value, 8 would be the y value, and 10 would be the hypotenuse. And so then there's your angle. Sine of theta would be 8/10. So we can say the sine of theta is 4/10 or 4/5, excuse me. Okay. All right. What angle is created by the terminal point? -2, -2. So -2, -2, if you think about it, is somewhere over here, right? -2, -2. And we're actually looking for this whole angle, if you think about it, whole angle. And so we know that the tangent of this guy, theta, equals -2/2, which would be 1. So that will tell you what this reference angle is. So when does the tangent equal 1? That's at 45 degrees. So if you do 180 plus 45 degrees, we would be at 222 degrees. So we could say 222 or 225 degrees, or in radians, I think we would go with 5 pi over 4. Okay, and this is just a little encouragement. True or false? True or false? Right? We're all at home. We can all spare 20 minutes. 20 minutes of homework a day keeps the F away. That is completely true. If you think it's false, maybe you subscribe to the statement of 30 to 40 minutes of homework a day keeps the F away. Maybe that's you. But anyway, I want to encourage you as we enter into a kind of like a whole new graphing scenario. This stuff is really fun and it's not that difficult if you stay consistent. All right, so it should be a great opportunity for us to learn some new stuff as well as for us to be successful in our learning. Okay, so first one, lesson 1, getting used to the coordinate plane. All right, so coordinate plane, we have an x variable, y variable, right? We have an x-axis, y-axis. If somebody says something like -2, -2, like we just saw, we're going to count over. I don't even know. That seems like where the origin is, right? So then I'll go call that like -1, and then we can call that -2, and then like -1, -2. So then you would plot a point. Boom, done. Simple enough. Now polar, what? Look at this thing, it's so dope. Looks like unit circle, okay, kind of. But now in the one that I'm using, I've got myself a few more things. Pi 12ths, which is, for those who don't know, pi 12ths is 15 degrees. So these are all going, oh my dog, hold on a second. What? Hold you? Can I hold you in like 10 minutes? Okay, I love you. Bye. All right. So anyway, 15 degrees, okay, is pi 12ths. All right. And so essentially those are going around. So what is polar coordinate plane like? What do we got? So I'm going to highlight something. Here we go. This origin is called the pole, okay? It would look like 0, 0 because the radius would be 0 and the angle would be 0. So here's what you're seeing. R is the radius, and theta, right, is the angle. And so the way we look at a point is we look at r comma theta. All right. So I just want to show you some of the graphs that can be made with this, just to kind of like bring out the wow factor a little bit. And so here we go. I'm going to go to Desmos because Desmos is the best. And it's actually really easy to do polar coordinates. So I switched over to a polar plane by going to the settings, and it's this grid right there. And so then it gives you the angles and everything. And so here is something that can happen. It's always r equals when it comes to polar. And so we can do like r equals the sine of theta, right? Now it's a little tough to see, but as you can see, that graph's a circle. Let's add some craziness to it. If I put a 4, now the circle gets bigger as a coefficient. What would happen if I put a 4 on the inside? 4 times sine of 4 theta. Look, it's a beautiful flower. This thing's glorious. What would happen if I put like -2? What? Look at these things. These things are amazing. Now, what if I said 2 theta? What? Look at this. This is out of control. Look at this. This is crazy, people. All right. So anyway, polar can get real wild, real fast. And it opens up a lot of possibilities. One of the things I want to point out, though, is that this polar equation is not a function, right? So like, it's not something that's going to pass the vertical line test. But also the beauty of polar is that you could not have really graphed this. I mean, you could have maybe, but in a much more difficult way. It would have been much more difficult to graph this in the coordinate plane using x and y as your variables, right? Like y as a function of x. That would have been very difficult to do because you'd have had to piece together because this is not a function. So polar presents to us a lot of cool opportunities that can get pretty crazy. So if you're bored at home during the quarantine, just mess around with this while also doing your homework. But it's like what r equals, and you do like sine of theta, and then do it like times cosine of theta. Now it gets real crazy. Oh, you can't see it's way in there. Look at this, look at this, look at this, look at this. Oh, you get a little baby flower. Look at that baby flower. That's kind of cute. So anyway, all right, so there you go. So polar can get pretty wild and be a lot of fun. We might do an art contest still. We'll see what happens, but be on the lookout. So today's goal, right, as we're going through this, is just getting used to the polar plane. The biggest thing that we're going to ask, right, is how do you plot points? Okay, that's all we're going to walk away with. How do you plot points? Get used to it, and it should be okay. So here's how it works. The first number tells you the radius, right? I already said that, but if you're looking at these concentric circles that are in the plane that I've provided you, there's your pole is at 0. The center, sorry, it's hard to make a dot. That kind of stinks. All right, so let's scrap the highlighter on one note and let's just go with like green. So the pole is here. That's 0, 0, 0 degrees, 0 radii, right? Then this would be a radius of 1, a radius of 2, a radius of 3, and a radius of 4, and you kind of get the idea. So if I'm plotting 4 comma pi fourths, then I'm going to go to pi fourths the angle. You ate all your goldfish? You need more. There's 5 in there left. Okay, let me finish this and I'll get you more. Sound good? Okay. Goldfish are life. Okay, so anyway, pi fourths, all right, is the angle I would go to, and then I'm going to go out 4 because that's my radius. So 1, 2, 3, 4, and I plot a point right there. So that would be point A. Okay, pretty straightforward. If we're saying that every 12th pi 12ths is 15 degrees, right? Then each of these angles are going by 15 degrees. So 285 degrees would be what, 215 or 270 plus 15. So you're going to do the angles as you would always do the angles in the unit circle. So I'm going to start at 0, right? And I'm going to go around to 285, which would be this guy here. So 285 is there, but I'm going to go out 2 as my radii, and so that would be B. Okay, so when everything's positive, that's how you would plot the points. Okay, so we're just plotting points today. We're not drawing any of those cool graphs that you saw. All right, so now what do we do if the angle is negative, right? If the angle is negative, you graph the angle. Okay, so this is not your first like unit in a trig class, right? So if we see a negative angle, that means we're starting at 0, but now we're going this direction, right? That means we're going clockwise. So negative 7 pi 6 is going to be the same as 5 pi 6. So that's all it is. We're there. It's like coterminal angle, but we want to go in that direction to find it. And then 5 would be our radius. So I'm going to go out 1, 2, 3, 4, and 5. And so that's where C would be. Okay. Where it gets tricky is not if the angle is negative. Where it gets tricky is it gets tricky if the radius is negative. So what that means is you're actually going, I don't know what the best way to say it is. Maybe you'll go in the opposite direction. So let me try to put it this way. So negative 2 pi thirds, we're going to graph it like we always have. So we're going to go this direction. That means we'll be at 4 pi thirds. And then negative 3. So instead of coming out 1, 2, 3, we're not going to come out 1, 2, 3 that way. We're going to go the opposite way. So reflected essentially over the pole. And it's going to reflect over the pole or the origin, right? So 1, 2, 3. And I'll put a point right there. So that's going to be D. Okay. So when the radius is negative, it doesn't go out from the pole in that direction towards the angle. It goes in the opposite direction away from the angle. Could be another way of stating it. All right. So here's what I would encourage you to do. If this all makes sense, go right here, okay, to the pop quiz, press pause, okay, press pause. And then what I would encourage you to do is try to figure out which quadrant these points are going to be. Here's R, here's theta. Remember, it's the point R comma theta. And if you want to copy over a coordinate point or a polar plane to help you out, I would add it in. But press pause and try and do it on your own. See if you can state the quadrant that these points would be in. All right. Otherwise, I'm going to just give you the answers, and hopefully I can do it in my head and do it correctly, because I'm kind of a visual person, but I can do it. I believe in myself. All right, so here we go. Negative pi over 6 would be in quadrant 4, but since it's reflected over the pole because of the negative radius, this would be in quadrant 2. Okay. Negative 11 pi thirds. Oh, good grief. I think this would be in quadrant 1. All right. 23 pi 12, so that's going to be almost all the way around, so it's quadrant 4. Negative 11 pi 6 is quadrant 1, and it'll stay there because the radius is positive. Negative 9 pi over 4, so 8/4, and then 1 more 4th is going to put you in quadrant 4, but then reflected over the pole would be quadrant 2. Okay, 11 pi over 6, that's quadrant 4, but then reflected over the pole is quadrant 2. Negative 7 pi over 6, we just said was in quadrant 2, but then reflected over the pole with the negative radius would be quadrant 4. And then 9 pi over 4, positive, is in quadrant 1. And that's where it is. All right, so hopefully I did that right. Let me know if I didn't. Drop me a comment or something like that. But that's kind of the idea, is we're just trying to figure out where we would plot these points. Because as we move forward, as you saw, we're going to do some graphs. We're going to take a look at some of these things. We're going to learn how to manipulate the next time between the r comma theta point and then manipulate to x comma y and see the relationship between the coordinate plane and the polar plane. So should be good. All right, here we go. Let's move on. I just want to finish it. If you understand everything I'm saying, then you should be able to play this game with me. So this game is called Name That Point. Okay, it's a really fun game. All right, you just kind of like yell it out. All right, so given the polar point, so we have 2 pi-thirds. Given the polar point, state 2 more polar points that would create the same point. So the idea here is that you can find lots of points that are not the same exact thing, 2 comma pi-thirds, but you can find lots of points that will land at the same spot. All right, so we're gonna name 2 more. So 2 comma pi-thirds. Let's graph it to see where it is. 1, 2. There we go. 2 comma pi-thirds. So there's point A right there. All right, so point A is right there. So what I'm saying is you need to come up with 2 more polar coordinates, all right, that would graph the same point. Okay, so if you want to hit pause, go ahead, hit pause, try it on your own. You can yell it out loud if you want, okay? That would be good, but I'm going to throw a few out there. So I'm going to go one with 4 pi-thirds as my angle. So right, that's here. Okay, 4 pi-thirds, but then I'm going to have to use a negative radius, -2. Okay, now I'm going to do one with a negative angle. Here we go. If I was doing a negative angle, I would say like -5 pi over 3, but I want to keep the radius the same because I don't want it to flip. So it'd be 2 comma -5 pi-thirds. So I got another one here for you if you want to give it a shot. Okay, you could hit pause and do it all on your own. Plot the first point and then try and come up with 2 points that would create the same thing. Pretty fun game. All right, name that point. So here we go. -19 pi over 12 means I'm going to find myself about right here. Okay, and then -3. So I got to go reflecting over the pole. So 1, 2, 3. So this is B. Okay. All right. So I want something that's there. So probably the easiest one to do is everything positive. So 3 and then 17 pi over 12. Right, would be there. And then I could do a negative angle. What would that be? That'd be 1 12, 2 12, 3 12, 4 12, 5 12, 6, 7 12. So I could do like 3 comma -7 pi 12ths. If I wanted to do a negative radius, I could do like 5 pi over 12, where that ended, the first one ended, 5 pi over 12. But then maybe I do -3 as well because I don't want to reflect over the pole. So you got lots of options there, but it's just kind of a fun exercise to see if you really are getting how the points should be plotted. Okay. If you have any questions, please contact me. You can figure that out however you want to contact me, but I'd love to help. So we're in polar, in the polar plane, polar equations. It's going to be a lot of fun. Do your homework. And I will talk to you guys later. All right, so peace out. All right, how do you stop recording?